Hello friends, welcome to our YouTube channel. The purpose of this channel is to help students learn from the comfort of their homes. So let's move ahead. In today's video, I have brought for you exercise 2.2 from the chapter Polynomials, that is the second chapter of 10th class. So let's start. Now, learning of the fundamentals. If alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c equal to 0, where a is not equal to 0. Why should a not be equal to 0? Because if a is 0, then ax square will not exist. And if x square is not existing, then the polynomial cannot be quadratic. Right? So if a quadratic polynomial ax square plus bx plus c equal to 0 has two zeros which we represent by alpha and beta, then there is a relationship between the coefficients of the polynomial and the zeros. What is that relationship? Sum of zeros is alpha plus beta, and that is also equal to minus coefficient of x upon coefficient of x square. That is, it is equal to minus b upon a, where a, b and c have the standard meanings. A is the coefficient of x square, b is the coefficient of x, and c is the coefficient, actually the constant term. So product of zeros is alpha into beta, and that can be found out by finding the ratio of the constant term, that is c, to the coefficient of x square, that is a. So it will be equal to c upon a, right? Let us take a quadratic polynomial. Px is equal to 3x square plus 5x minus 2. Now if by the method of splitting the middle term I solve this polynomial, or I factorize this polynomial, I get 3x minus 1 into x plus 2. I'm not going into much detail of how to factorize by splitting, because that is something that we have been doing since 8th standard. So I just directly say that the splitting gives us this factorization 3x minus 1 into x plus 2. Now the value of 3x square plus 5x minus 2 will be 0 when either 3x minus 1 equal to 0 or x plus 2 equal to 0, which means either x is equal to 1 by 3 or x equal to minus 2. Therefore friends, the two zeros of 3x square plus 5x minus 2 are 1 by 3 and minus 2. So now let us think what actually the relationship between these zeros and the coefficient mean, and how can it be verified, right? So here in this particular example only, the sum of zeros alpha plus beta will be equal to 1 by 3 plus minus 2, because that are the two values of the zeros that we have obtained. Solving them, we get alpha plus beta is equal to minus 5 upon 3, right? And if we find the sum of zeros using the formula minus coefficient of x over coefficient of x square, then again we also get the sum equal to minus 5 upon 3, right? So both are equal. Now the product of zeros alpha beta will be equal to 1 by 3 into minus 2, that is minus 2 by 3. Finding it using the formula, the product will be equal to constant term upon coefficient of x square, that is c upon a, and that would be minus 2 upon 3 again, right? So even this is equal, right? So by showing these calculations, we can say that the relationship between the zeros and the coefficients is proved or verified, right?
Subscribe to our channel and hit the bell icon to continue receiving all notifications as we post new videos.
So if alpha and beta are given the zeros of a quadratic polynomial, then if you need to find the polynomial whose zeros alpha and beta are, that can be done by using the following method. First of all, we'll find the sum of these two zeros, alpha and beta, right? Secondly, we will find the product of zeros, that is alpha into beta. Then by simply using the formula, that required polynomial is x square minus sum of roots x plus product of roots, we would have obtained the quadratic polynomial whose zeros are given to us, right? So required polynomial is x square minus alpha plus beta into x plus alpha beta. So let us do the first question of the exercise 2.2, right? Find the zeros of the quadratic polynomials, and we have to verify the relationship between the zeros obtained and the coefficients. So a few questions are given to us, 6 of them. We need to first find their zeros, and then we need to find the relationship between the zeros and their coefficients. So I will do two parts for you, and rest you can do on your own, right? So starting with the third part that I'll be doing for you first. So third part is cx square minus 3 minus 7x. Now first of all, friends, we need to put that in order. So 6x square minus 7x minus 3, because we need to arrange the polynomial in the standard form, that is ax square plus bx plus c, right? So after that we will be doing the middle term splitting. So 6 into 3 is 18, right? So I need a pair of factors of 18 whose difference is 7, and that is 9 minus 2. So 6x square minus 9 minus 2 into x minus 3, right? So I get 6x square minus 9x minus minus is plus 2x minus 3. So taking out 3x as common, I will be left with 2x minus 3 inside, plus since the HCF of 2 and 3 is 1, so we will only get 1 as common, right? So taking out 2x minus 3, we will be left with 3x plus 1, right friends? So 6x square minus 3 minus 7x is equal to 2x minus 3 into 3x plus 1. Also, we need to identify what a, b and c are for this particular expression. So here a will be 6, b will be minus 7, and c will be minus 3. See, the comparison is with ax square plus bx plus c, and that is why we are considering these negative signs. We are taking them along with here, right? So now to find zeros, first of all, we'll find the zeros. To find zeros, put the polynomial equal to 0, right? So 2x minus 3 into 3x plus 1 is equal to 0. So either 2x minus 3 equal to 0 or 3x plus 1 is equal to 0. Either 2x is equal to 3 or 3x is equal to minus 1. Either x is equal to 3 by 2 or x is equal to minus 1 by 3. Right, so these are the two zeros that we obtained. I'll take any one of them. Let I suppose alpha be equal to 3 by 2 and beta is equal to minus 1 by 3. Right, so the next thing that I have to do is to verify the relationship between the zeros and their coefficients, right? So what I will be doing is,
So verifying the relationship, what we have to do is that we will need to put these values of a, b and c in the formula that relates the sum and product with their coefficients, right? So we have obtained alpha is equal to 3 over 2 and beta is equal to minus 1 upon 3, right? Now we know that sum of zeros is alpha plus beta, and that is equal to minus b upon a, right? So first let us solve alpha and plus beta. So I get 3 by 2 plus minus 1 by 3, that is 3 by 2 plus minus is minus 1 by 3. LCM of 3 and 2 is 6. So 9 minus 2, I get 7 upon 6. Now when we speak of minus b upon a, since b, as we saw, is minus 7. So minus of minus 7 upon a is 6, we get 7 upon 6. So LHS is equal to RHS in case of sum of zeros. Then the next thing is product of zeros. Now product of zeros is alpha beta, and it is also equal to C upon A, right? Solving alpha beta, I will get 3 by 2 into minus 1 upon 3. So 3 and 3 get deducted. So minus 1 by 2 is the answer. So C upon A, as we saw, C is minus 3 and A is 6. So doing the cutting, we again get minus 1 upon 2. So LHS is equal to RHS, right friends? So hence, we have verified. What have we verified? The relationship between the zeros and the coefficients of the polynomial, right? I hope you would have understood it. Now taking the fifth part of the same question for you. T square minus 15. Let me represent it by PT. So PT is T square minus 15. So I can say T square minus 15 is root 15 ka whole square. So using the formula, A square minus B square is equal to A plus B into A minus B, right? Here A is T and B is root 15. So I will get T plus root 15 into T minus root 15. Now what do we have to do? What do we have to do to find the zeros, right?
Now to find zeros, we will put this polynomial pt equal to 0, right? So we get t plus root 15 into t minus root 15 equal to 0. So either t plus root 15 is equal to 0 or t minus root 15 is equal to 0. So t is equal to minus root 15 or t is equal to plus root 15. Now, one thing and a key point for you to remember, whenever a polynomial has a non-perfect square root as one of its zeros, it is certain to have its conjugate as another zero of the polynomial, right? So if root 15 is a 0, minus root 15 for sure would be a 0. Now to verify the relationship between these zeros and the coefficients, first let us find out what were A and B, right? And C. So this was our polynomial, friends. Here Obviously, if I compare it with at square plus bt plus c, I have a equal to 1. I have c equal to minus 15. But what about b? I do not have a term which has t in it in the polynomial. So therefore take b as 0. Right? Now let me consider this as alpha and this as beta. Right? So starting with the verification. Now sum of zeros. We know alpha plus beta is equal to minus b upon a. So solving alpha plus beta will get minus root 15 plus root 15, and that is equal to 0. Solving minus b upon a will get minus of 0 upon 1, that is 0. Right? So alpha plus beta therefore is equal to minus b upon a. Now the second thing is product of zeros. Now as per the relationship, alpha beta should be equal to, that is the product of zeros should be equal to c upon a. So in our case, minus root 15 into plus root 15 is alpha beta. So that should be equal to root 15 into root 15 is 15. So alpha beta becomes minus 15. And if we take c upon a, c is minus 15 and a is 1. So even c upon a is minus 15. So obviously alpha plus beta is equal to minus upon b upon a is true, and alpha beta is equal to c upon a is also true. So friends, this is how we can verify how the relationship between zeros and the coefficients can be find out and verified. Right? Question number 2 of exercise 2.2 is to find a quadratic polynomial when we are given with the sum and product of its zeros. Again, we have given a few parts. I will do one or two for you and rest you can do on your own. Right? So let me do the second part for you. So root 2 and 1 by 3 are given as the sum and product of 0. Right? So sum of zeros is equal to root 2 and product of zeros is equal to 1 by 3. Now it has two ways in which this question can be done. The first one is the formula method. Formula method. Formula that we have learned is that if given the sum of zeros and the product of zeros, then the required polynomial is equal to x square minus sum of zeros into x plus product of zeros. This is the required polynomial, right? So in here, if I just insert the values that have been given to me, that is x square minus, in place of sum of zeros, I write root 2 x as it is plus 1 upon 3, then it can be my required polynomial. So solving it ahead, the required polynomial px will be equal to, taking LCM, 3x square minus root 2x into 3 plus 1 whole over 3. So that is 3x square minus root 3 root 2x plus 1 over 3, which can be written as 1 by 3 into 3x square minus 3 root 2x plus 1. Now friends, whatever we are getting here in the multiplication, we can simply replace it by k. So px is equal to k into 3x square minus 3 root 2x plus 1, where k is any real number. K is any real number. Right? Alternatively, I can do this question in a different way. How would I do that? We will take sum of zeros. Sum of zeros is minus b upon a, and that is given equal to root 2. And product of zeros is c over a, that is given equal to 1 by 3. I will try to make the denominator of both these, this one and this one, the same. Since it already has a denominator of 3, so I will simply multiply divide it by 3 to get 3 root 2 upon 3. Now in either case, a becomes 3. So I am supposing the same. Now let a is equal to 3, right? Then what will be b? Minus b will be equal to 3 root 2, which means b will be equal to minus 3 root 2, and c will be equal to 1, right? So required polynomial can simply be px is equal to ax square plus bx plus c, that is 3x square minus 3 root 2x plus 1, same as what we obtained earlier, right? Doing another part where sum and product is given as 0 and root 5. So directly putting it in the formula, x square minus sum of roots into x plus product of roots I will get x square minus 0 into x plus root 5, that is x square plus root 5. Similarly, with given that sum of roots is minus 1 by 4 and product of root is 1 by 4, putting it in x square minus sum of roots x plus product of roots, I will obtain x square minus 1 over 4 x plus p, that is product 1 by 4. So x square plus 1 over 4x plus 1 upon 4. Taking 4 as LCM, we get 4x square plus 1x plus 1. So again 1 by 4 into 4x square plus x plus 1, and I will replace this 1 by 4 by k, because it can be any real number, not just 1 by 4 only, right? So isn't it quite easy? Yeah, and interesting as well. So where k is any real number, so we are able to find the polynomial whose sum of zeros and product of zeros is given to us, right friends? For more informative videos, subscribe to our channel and also hit the bell icon so that you are notified whenever we release a new video. Thank you from Horizons.